So I am an AIMA student in the first year of master. I am currently doing my internship with Thierry Fournel and Loïc Denis. The subject is patch analysis to point anomalies out when querying a database of all ornaments. And this internship is as part of the ROII project with what we call IRIM, which is the Institute for History of Representations and Ideas in the Modernities. So globally, the aim of my internship is that we have a query image. We pass it through an algorithm. This algorithm will give us a heat map, and this heat map will be used by an expert to make an authentication to determine if the query image is a counterfeit or not. So to do this, first we have to do first a learning of the multivariate Gaussian model of the database collections fluctuations, which the Gaussian model is a model which allows us to determine and to search for the relationship between at least two variables. And then after we have doing this, we have to determine to which category belongs the query image. To do this, we use the bag of words method to search for the closest collection to which the query image belongs. And first, we have a splitting of images into two sets, first the training set and then the test set. So first, for the training set, we have the features that are extracted from the training set. Then we have the creation of the visual words thanks to these features. And after this, we have a histogram creation from training classes. And this histogram represents the frequency of the visual words for each category of images. After this, we have the testing set. We also have first the features that are extracted from the test set. Then we have a histogram creation for the testing phase. So here, the histogram represents the frequency of the visual words, but this time it's for each image of the test set. And after this, we have an assignment of a class to each test image as formed as a confusion matrix. And this confusion matrix allows us to measure the quality of a classifying system, where all the rows are the known classes and the columns are the predicted ones. So after learning the multivariate Gaussian model of the database collections fluctuations and use the bag of words method to search for the closest collection to which the query image belongs, we have in the last step to compute the Mahalanobis distance for a sliding patch to get the heat map. And the Mahalanobis distance is the distance we can measure between 2 points, but in a multivariate space. So here it is. Thank you.
Thank you. So maybe I let other people questions. So I will have a question, but maybe, I don't know, Cécile, how we can unraise some hand. Because Nathalie has...
It's not you, it's each person.
Okay.
Unraise.
Okay.
You cannot do that.
There are many questions. So there is a question from Anne-Claire Legrand. So can you read it in the chat?
I'm going to try. Maybe I'm going to stop the sharing, or maybe not.
Did you test other configuration routes of bag of words to take into account the spatially information, the position, and the spatial correlation of the features?
No, I only have tested the bag of words method, and there is some problem still. So I am trying to fix the problem with the bag of words method, but I didn't test anything else.
Okay, and there is a. So can you go to a previous slide, please?
This one maybe. This one.
Yeah, this one. In fact, I would like to see the table at the bottom
confusion
right.
matrix.
Yeah, to see what are the performance of your system. So
I'm going to do like this. So this is a test that I have done first. Yes, this is the first test that I have done with MATLAB, and this is someone who has developed the code. It's not mine. And okay. According to the parameters we can put, we have different accuracy percentage. Here we had different parameters, and the accuracy was 66%. But I have done some other tests, and there were better and lower scores.
Okay. And Baptiste Julie has a question. He asked, how are the visual worlds created?
For the training set? For the training set, we have the features that are extracted, and all of these features extracted are the visual words.
Okay.
Each feature extracted represents a word, one word.